Hey everybody, this is Larry. This is day 3 of the July League of Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm. I just did one of my harder running training today. Also because I did squats yesterday, so I was a little bit tired on the leg, some parts of my legs, and I ran about 11 miles, 8 of them at a strong pace. So we'll see how that goes. But today, let's look at today's farm. I think I missed Canada Day. Is that so? Happy people who celebrate maybe belated Canada Day. Happy Canada Day. 4th of July is almost here though, so happy Independence Day for those of you in America, or I guess elsewhere if you celebrate it. And long weekend, yay! If for some of us, I suppose. I mean, for me, it's always a long weekend. For me, yeah, so it's great. Anyway, today's farm is 1509. Minimum differences between largest and smallest value in 3 moves. Okay, what does that mean? You're given an integer array nums. In one move, you could choose one element of nums and change it to any value. Return the minimum difference between the largest and the smallest value of nums after performing at most 3 moves. Okay. I mean, I think the couple of things you can do, and the way that I would think about it, I mean, maybe I'm just trying to think whether it's easy to do a sorting type thing, but really, sorting makes it easy to implement, but the idea doesn't need sorting. And the idea here is that, okay, let's say you did sort it, right, as a proof. Let's say you did sort the problem, then as a proof, then what does that mean, right? So let's say you have, I don't know, a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, I guess, right? Man, I need to write more, I think. A sub 9, a sub 10, and a sub 11, right? These are just like numbers, right? Maybe add an a sub 8. So, there's a bunch of them, right? Maybe you could say n minus 1, It doesn't matter, right? And they're sorted, so that means that this is the smallest value, this is the biggest value, this is the second smallest value, this is the third smallest value, and this is the largest value, second largest, third largest, right? So what are we exactly doing here, right? Well, let's say you make one move, then the move that you're going to do, you can do. So there, you can think about it as n choices, right? Kind of, maybe, right? But would any of them make a difference? Probably not. Not most of them. The only real thing that you can do is changing either a sub 0 or a sub 11, right? Or a sub n. They just call it a sub n, right? Or changing a sub n, right? Yeah. I guess now I need n minus 1. It's easier to say. And technically, I guess we have 0 index, but okay, whatever. So you got to change this with one. So making one move, you could either change this or you change this, right? So that means, and the reason is that, and it doesn't matter what you change it to, because you can really change it to any of the other numbers, and by definition, then now the observation is that as soon as you change this to any other number, as long as you're not being silly and change it to like a bigger number than a sub n or a smaller number than a sub 0, but you choose any number between a sub 1 and a sub n, it doesn't even matter if it exists, it doesn't matter, right? But what that effectively does is that now it removes a sub 0, so then the difference between the largest and the smallest is this, right? Okay, so that's one thing that you can do. The other, of course, is just choosing minus a sub n, right? Because again, that's the only thing that might change the result. And again, what I was gonna say, yeah, it's the same idea but symmetric, so I'm not gonna go over it too much, right? Because then now you move this, then you have this, and so forth. Okay, what about 2 moves? Well, one move that you can do is just remove a sub 0 and a sub 1, right? And I say remove, but it actually is just changing it to whatever in between, but it's the same idea anyway, right? And or you could also remove 2 from the end, or 1 from the end and 1 from the beginning. So that's basically the idea, and you can think about it as maybe a sliding window if you like of, you know, maybe if you, I don't know, depends how you want to do it. But yeah. So that's basically the idea, and with that, and you know, with 3 moves, up to 3 moves. But you always want to make 3 moves, and that's less than 3 elements, maybe. That's a little bit awkward, actually. But yeah. 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 3 moves, you can make either 3 in the beginning, 3 at the end, or some combination of what we talked about, right? Like, for example, 2 from the front, 1 from the end. That's good too, right? And what does that mean? That means that here, then now, if you remove 3 from the beginning, then you have a sub n minus a sub 3, right? Or a sub n minus 1. My indexing is a little bit off because I use 0 index and this is a sub n. So maybe we'll start at a1, a2. So then this is actually a4, right? Let's keep it consistent for 1 based. And here it's just q sub 2. And then a sub n minus 2 minus... Wait, what? Wait, what am I doing? So we move 1 here. And then you remove these 2, right? So it's a3. And then n minus 2 is remove 2 here and 1 here. So this is a of 2, or a of n minus 3, which is not the thing, minus a sub 1, because it's just minus these 3, right? So that's basically the idea. And you can actually just like write out, you know, we could actually write this out literally. You know, maybe n is equal to length of nums. You know, if n is less than or equal to 4, then we return 0, right? Because you have 4 numbers, then you just change 3 of them to the same one. It doesn't really matter. Though, yeah. So here, and then now we have best is equal to just like some infinity value, right? I like this one. And then you can just, if you're really lazy with the for loops, you could even just write like, you know, num sub the biggest number minus num sub the third number. Hopefully this is right. It's very easy to make silly mistakes, and I've been making them a lot. Yeah. And that's it, right? I mean, of course you could write this with a for loop, but I just want to illustrate that, you know, you don't even have to sometimes, and it's okay. Unless I get a wrong answer like this one, probably during a contest, and it would make me sad. Oh yeah, I did it this way. Why did I miss 2 cases? I don't know. I guess I misread this as maybe, I don't know, I have to watch the video or something, but maybe I misread it as always 3 from the same side, and that didn't really make sense, and it took me 2 minutes to kind of just clear it up and fix it, which is, I didn't write a for loop that time either, and I also printed out, which I guess is fine. But how did I do that contest? Today, I guess today I'm a little bit clearer, but that contest not so much. I'm just curious. It's a bi-weekly. Oh, Avice won that one, and I did not do well in this one. Oh, because of Q4? What was this Q4? That someone got in like a minute. That was DP. Why did I take so long? I think this is the one that I wasn't able to prove complexity. But I kind of wrote it in a funky way as a result. But yeah, you could actually have, I guess, yeah, people are just very clever. I think it's just end square root of it. Anyway, that's a different problem. We don't have to think about that one. But yeah, what is the complexity here? Well, this is just O of 1. Oh, well, this is just, I forgot that I sorted. So it's n log n. But you don't have to do this. You can just keep track of 4 numbers, right? Or yeah, I guess 8 numbers. Four smallest and 4 largest, right? So yeah, so in this case, you could just do that, put in 4 variables or something like this, or an array with 8 elements or something like this, and then just do it that way. That would, and you are able to get the 4 smallest and 4 largest in linear time. Just with a lot of if statements, even if you don't know how to do it. You can also do it with a log4 heap if you like, to get the 4 smallest and the 4 largest. And then do it the same way. So in theory, you can do this in linear time and constant space. I did not because of sorting. It just makes it easier to write, right? I don't know. Whichever one you prefer, but definitely during an interview, definitely talk about that a little bit. I am curious if they do it that way. Yeah, they do the sorting, but partial sort and greedy deletion. Yeah, I mean, that's basically the idea. I mean, that's not... why would you call it partial sort? It's just regular heap. Top K problem. But yeah, that's all I have for today. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.